Hello everyone, this is Maths Fundamentals. In this lesson, we are going to see how we can calculate for the shortest distance. Remember, we are still under earth geometry. Shortest distance is the distance between 2 points of an arc which cuts straight from one end of the arc to another without following the curve, or it is a chord, okay? Here is a picture of what we are talking about. As you can see, we have the globe there, or Earth's surface, showing some longitudes and latitudes. Now, if you see there is KL, which is more of a curve or an arc. But we have M, which is the straight line. That is the shortest distance we are talking about. Now, let me show you a cross-section of this point, which is in this diagram. So as you can see, we have KL. So M, that distance from K to L, we've named it as M. That is the shortest distance they're talking about. If you compare with the diagram on the left, you can see that the diagram on the left, it has a curve or an arc, which is KL. So we've removed that so that you see a cross-section when we extract this thing. So we have R. Remember, R is the radius. And from what we can see, that radius is the radius of a small circle, okay? So it is not mentioned here. We have to examine it and find it. Yeah, so basically that's what it is. And we have the angle theta there, where KL stem from, okay? From that particular latitude. So we also have to find that angle between these 2 points which are along the latitude, which is theta degrees. Now, let us see something also to help us understand how to calculate for the shortest distance. So, we have another figure here for calculating the shortest distance. Yes, this is the original picture. Remember? And here is a cross-section now, where it also has the arc or the curve at the end. So, our target here is to come up with something that will help us calculate the shortest distance. Remember, the shortest distance is M, and we don't have any details that are given for us to find M. So, what do? I've divided this figure into 2 equal parts, as you can see. So, from this figure, when I've divided this into 2 equal parts, from here up to here, it is M. So if I divide M into 2 equal parts, then I'll have half M. From here going this side is half M. Even from here going this side is half M. So I have this side as half M, which is M over 2. Okay? And again, this angle here on top, which is theta, I've divided it into 2 equal parts, this angle, which means this part is same as half theta. It's one and the same thing. Now, how do we find M? We'll find M using trigonometric ratios. What trigonometric ratio am I going to use to find M? So for me to find M, it means I'll have to use this side, which is half M. It has M. And also use this side, small r. Which trigonometric ratio uses the opposite, the side which is opposite to the angle we want to use, and the hypotenuse. It is sine. Therefore, I'll construct my formula as sine the angle, which is half theta. So sine half theta is equal to, opposite is M over 2 over R. I will multiply these using the reciprocal or cross multiply. So when I cross multiply, it will be M over 2, which is equal to R times sine half theta. Now, I want to remain with M alone on this other side. What am I going to do? I will multiply again both sides with the reciprocal of half, which is 2. This side I'll remain with M, and the other side of the equal sign, it will be 2 small r sine half theta. Remember now, this r is the radius of a small circle. So how do we find the small circle radius? we have done this already. So small circle radius, we've figured out that it is small r is equal to capital R cos alpha. Therefore, I'll go ahead and substitute where there is r, I'm going to put r capital cos alpha. And it will be something like this. M is equal to capital R cos alpha sine half theta. Okay? And I'm done with that one. Finally, I'll have my M as M is equal to 2 multiply everything that is inside, that is R cos alpha sine half theta. Therefore, the shortest distance formula is 2 times R cos alpha degrees times sine half theta degrees. And that is how the formula is derived. This is the formula you are going to use to calculate for the shortest distance. So now let us solve this example. I'll get the formula that we've just derived or constructed. From there, I'll put the necessities. Capital R is the radius of the earth. I'll put it there. Theta, it is the angle difference between K and L. So I'll add because they are on the opposite of the prime meridian. So 52 plus 63 is 115. Finally, when you punch those on your calculator, that will be the answer, 8,057.6664001 kilometers. And you're done. Congrats! You've just used the formula that you've derived to come up with the correct answer. So, in the next lesson, we are going to look at how to calculate for time, and we are going to see what a nautical mile is.